Hello everyone, welcome to our presentation. My name is Sumit Kumar. I am a program manager in the Microsoft Machine Learning Group, and with me is my colleague Vijay.
Hello everybody, my name is Vijay Jaisilan. I am an engineering manager in the same group as Sumit.
We are super excited today to talk to you about the new capability that we are bringing in SQL Server 2017. So with native integration of Python in SQL Server 2017, Python is effectively a peer to R language that we added in 2016. So now, in addition to R-based machine learning and advanced analytics applications, you can also run Python-based machine learning, AI, and advanced analytics applications in SQL Server. And so what this also gives you a capability to do is deploy a Python-based machine learning application in enterprise production environment, which is already running on SQL Server, right? So in addition to that capability, what this integration gives you is the ability to bring any open source Python package and make it run in SQL Server so that you impart the intelligence from that open source package into your data, which is already in SQL Server. What are the key advantages that are enabled by this integration? First, and the biggest one, is the elimination of the need to move the data from database to wherever you are doing your Python-based machine learning and compute. That is a very, very important capability because it gives you a number of benefits. Number one, moving data is not secure, and the amount of infrastructure that you have to build to move data around to do machine learning, that is also another problem. On top of that, oftentimes you cannot move big set of data, so you are forced to do sampling and do your machine learning on samples of data. With this now, you can do machine learning and your Python-based compute on the entire data set, which is in database, and data is not moving anywhere, right? So, and the second problem that people often have with operationalizing their machine learning code is, fine, the data scientists have done a great job and created nice models, but putting them in production in such a way that the applications, the enterprise applications, LOB applications can actually take use of that is a problem, right? Yeah. So now with this integration, what you can do is you can deploy your machine learning model and Python script right inside of a T-SQL stored procedure. We'll talk more about that in a bit. But what that gives you is, hey, any app that can talk to SQL Server and that can invoke a T-SQL stored procedure without even being aware that a Python script or Python-based model is running in the background, it just gets the intelligence from it, right? So in addition to that nice integration and the ability to deploy models in production, we also offer some performance and scale advantages. Vijay, why don't you tell us more about that?
Right. You know that as part of 2016 in database analytics integration, we did introduce a new communication channel to exchange data from SQL Server to the scripts which are running inside SQL Server. That is a very high throughput channel, and it's like a columnar-based compression channel. It's much, much faster than ODBC. So Python also, this integration of Python also uses that. Apart from that, you already know that SQL has in-memory column store, in-memory tables and column store indexes, which are very highly conducive for large-scale data analytics. In addition to all this, as part of the integration, we are also bringing something called Revoscalepy, which is equivalent to Revoscalar package, which we introduced.
So all the RX set of APIs,
set of functions, right?
We will have a Pythonic version of those?
Yes, we have a Pythonic version of those. And all of those are not bounded by memory or scale. Right? Like, for example, if you're doing a linear regression on a billion-row data set, you can easily do it on a very small scale hardware, right, without any memory limitation.
Excellent.
So that's like enterprise grade scale.
Fantastic. Moving along, what are the key scenarios that we enable by this? So the first one is the data scientist scenario, where the data scientist is working on their laptop or their desktop, and they're doing data exploration and modeling and trial. It's a very iterative process. So now, while you're still working in your IDE, you can connect to SQL Server and do your compute there on the box.
Yes.
So you can set your compute context to either local or to remote on SQL Server, and even though you are executing everything on your IDE, it is actually being done on the SQL Server machine.
Yes, so that's like one of the main advantages of the Revoscalepy package, which makes the local and remote compute transparent, right? So the data scientist doesn't have to leave his IDE to run something on SQL.
I think that is huge, right?
Yeah,
there is no more pushing data around,
Yes.
the IT team giving fragments of data to
Yeah.
the data science. All the advantages that we built in our services are now available for Python-based machine learning as well. So the next one is the application developers. That's our another persona that will benefit from this integration. So the data scientist team has created the models and the Python scripts. Now I want to, as an application developer for LOB applications or my business application, I want to take advantage of that.
Yeah.
Earlier, it used to be that that data scientist model will have to be literally recoded into whatever the LOB application language is, Python, Python or Java or C#, you name it. But now, all I as an application developer need to do is invoke a stored procedure. We already talked about it, right? So that simplifies my job drastically.
So another thing also as part of the application development operationalization is in a basic 3-tier architecture, assuming you had some Python code which you had to run for an ML, generally it will be running in the middle tier, and managing that Python execution and all that in middle tier is very cumbersome. Now you don't need to worry about it. It is as simple as calling a stored procedure.
Absolutely.
Right? You don't need to worry about what Python version is running. Is it patched? Is it secure? Everything is part of SQL Server. So that takes away a lot of pain in terms of operationalizing the Python code into SQL.
And as we've been talking about, the intelligence is truly with data.
Yes.
And applications don't have to worry about all of this.
Yes.
And this kind of intelligent application is no longer the domain of the AI experts and machine learning experts. So that's a big step in the direction of democratizing machine learning and AI.
Yeah.
So the next sort of persona that benefits from this is this integration is, of course, the owner of the database, which is the database administrator. Why don't you tell us more about that?
So like the database administrators are very particular about what gets run on the database, who has access to it, how the queries are using the resources, are they throttling? All those benefits are also there as part of the Python integration.
Because I want to control what an external runtime can do on my box.
Right. So the DBA can control that. Like, for example, we have something called resource governance, which we did introduce as part of SQL 2016 itself as part of our integration. The same applies for Python integration also, where an admin can choose to say, these set of logins cannot use more than 5% of the CPU. So the Python code cannot use more than 5% of the CPU, right? So that kind of a very nice governing allows the database administrator to finally control what it is the stuff is running on the database. Apart from that, there are detailed logs and views where the database administrator can really look what Python code got executed, who is executing it. So these are just regular part of the SQL Server management, right?
Excellent. So I can take advantage of the state-of-art technology and machine learning capabilities while still being able to control my resources on the box without worrying about security, etc.
Yeah.
Excellent. All right, so let's take a look at how sort of this actually, we talked about the data exploration scenario. So on the left, you have data scientist working on his Python IDE, and as he connects in remote compute context to the SQL Server, the script goes to SQL Server, execution happens there on the Python runtime, and the results come back to the developer's machine. And in case of the operationalization, and the application is basically connecting to SQL Server, calling a stored procedure. The compute again happens on SQL Server. It leverages the new system stored procedure that we created last time, in 2016, calls SP execute external script, and it now accepts Python in addition to R code. Now, let's take a look at the architecture. Why don't you tell us a little bit more about how we were able to achieve all of this?
Right. So some of this we did talk as part of the 2016 launch also. The architecture as far as R services integration and Python services integrations is concerned, it is nearly identical, right? Like for example, we did introduce, as you just mentioned, SP execute external script, which is a system stored procedure to execute external scripts. We used to support R with 2016. Now it has a language Python where you can submit Python scripts and it'll execute. The query comes to the SQL Server executes it. There is an external process called as Launchpad, which launches it. There is a concept like a runtime launcher. We have, with 2017, we have R launcher and Python launcher to launch different runtimes based on what is needed. And it gets launched and it gets executed and it connects back to SQL Server on the SQL Satellite high throughput data channel. I talked about it, right? It exchanges the data. Then the script executes and comes back. Conceptually, it is very simple. Think about it this way, right? You're executing a query in the SQL Server and the results come back. With external script, what you have done is you execute the query in the SQL Server. The results of the query actually go to the external runtime. They post-process is based on that. And that result actually comes back via SQL Server to the client back. It's just like an additional post-processing.
Got it.
It's as simple as that.
Excellent. Now let's take a look at a demo where we see all of this thing working. Let's see some code in action. What you're seeing here is Visual Studio IDE with Python tools. And you're seeing a very simple few lines of Python code, which does nothing more than running hello world. So if I run it here locally on my machine, it prints hello world as expected, right? Now let's see how would I take this code and run it inside SQL Server, leveraging our integration that we just talked about. So here now inside of SSMS, you're seeing the exact same hello world code as here. And what you're seeing is the special system stored procedure called SP execute external script that takes an external language script. In this case, the language is Python here, and the script is the exact same Python code. Let's execute this code. And you see the exact same output here inside of SSMS as well. So it's that easy to bring any external Python code and make it run in SQL Server. Now let's take a look at how the deeper integration with SQL is done in this case. Vijay?
Okay, let's now look at another example which shows the SQL and Python integration in a bit more depth. What you're seeing right now here is basically a SQL script where I have a temporary table called as Python test, which has a day of week as a string and some amount associated with it. I have some piece of data which is put into it as the script runs. There are a couple of parameters which I'm printing the value, right? And then I am again invoking the same SP execute external script, which Sumit just showed you in the hello world example. And the language is Python here. What the script also does is it does a hello world, then it's changing the parameters, right? Which is basically some integer it's assigning. But at the core of it, what the script is doing is essentially it gets whatever the data set was passed into to the script through the SQL integration and it assigns to the output data set. So in this case, remember that we would have got a string and a float, right? What the script does is it has a map which maps the day of week from a string to an integer. And it just replaces one of the columns in the output data set, which is basically a pandas data frame. The input data, as you see, as I just explained, comes to a query, which is coming from the temporary table. And there are some parameters which are being passed in. The rows per read, paramint, and paramchar, which are the two parameters are output parameters, which the script can change. Now let's run it and see what is the output we see. So here you'll see very clearly before and after. So you see the strings where here days of week was as a string, and then it got converted to days of week as an integer. The amounts have been retained. So in this particular case, what you just saw was the data coming from a SQL Server table being used by SP execute external script, Python doing some sort of a very primitive ETL processing of converting a string to an integer value, and then outputting the data. Now let's look at the parameters also. Apart from the input and output data set, you can pass input and output parameters also. Now here, when I kind of switch over here, the parameters were, when they were going in, they 1, 2, 3, 4, 5, 6, 7, and a string parameter was of type input. And when the output came back, it is basically to and output. Literally, like some parameter was passed in, the script changed the parameter, and those values also came back. Now, another thing to remember in this kind of integration is sometimes what happens is the data could be pretty large, which is coming in. So we do have a concept called a streaming, which is supported. And the way you control that is a special parameter, which is rows per read, right? In this particular case, the rows per read was 5, which essentially says at a time, give me 5 rows. And the total number of rows were 10. So in the output, you see the script got executed twice. As you can see, the hello world getting printed twice. But the output, when you see, it's all merged and it just shows 10 rows. So literally what you saw here was a streaming behavior also. Okay, now let us show you some the Revoscalepy demo also. So let me switch over to the Python IDE, which is the PTVS as part of Microsoft Visual Studio. Here, what we have is a Revoscalepy package. There is a series of constructs there. And what we are trying to do there is basically we have a data source called as SQL Server data, which can realize it as a data frame or pandas data frame in Python. Then we have a concept, something called compute context, which essentially says where the code should be running. In this particular case, I'm saying the code should be running on the SQL compute context. And the function which we are trying to do is a linear regression, which is part of the Revoscalepy package, which is rxlinmod. And we are regressing one variable airline delay against day of week. The source is like the SQL Server data source, and the compute context is the compute context. And let's run it and see what we see. I'm going to switch over and kind of run it this from the command line here. So if you see here, I'm running, and as you see, with the rxlinmod SQL Server compute context got executed, and the results are coming back. Please note that here what happened was, although the script started in the client IDE, the computation was pushed to SQL Server, and the linear regression actually was done on the SQL Server using the data which was on SQL Server, and the results came back. Okay. Now let me switch.
That's excellent. So you're running an IDE, but the computation is actually happening on SQL Server.
Yes.
And you can test your script on the entire set of data that is there.
Yeah, so this is a very kind of a favorite data scientist scenario where they tend to work on local compute context, and then as they're ready, before they push it into production to SQL Server, they can test it against SQL Server, right?
All right, so that was excellent. Now, not only can you use the native integration and the basic default libraries and the Revoscalepy library that we are adding, you can literally bring any other external Python package and make it run into SQL. Let me show you an example of TensorFlow, right? So in these few lines of code, I am here, I'm importing the TensorFlow, and all that I had to do was just do a regular pip install of TensorFlow in the right path. Let's execute this. And from T-SQL environment, I'm now able to run the very basic hello world from TensorFlow. So that shows the power of this integration that enables you to bring any other external library as well. So let's quickly summarize. What are the 3 things that we saw in the demo? First one is it's extremely simple to lift and shift your Python code from outside to T-SQL environment. We saw how using Revoscalepy package, you can do remote compute context, and you can leverage the, you can do ETL inside of T-SQL, and you can leverage the additional algorithms that we have added in the package. And the third thing is you can bring any other external package and make it run in T-SQL. So hope you got a quick glimpse of the integration. We will continue to do more detailed demos, and we'll put code out on GitHub. So we saw Python integration in action. Let's summarize what are all the things that we're getting with this integration. First of all, Python, the new language, is natively integrated in SQL Server, which eliminates the need to move data for doing Python-based data science. Once you have the model, you can easily operationalize it for production environment. And the best thing is, it is available in all editions of SQL Server.
Yeah, that's great.
Thanks once again for taking time to watch our presentation. We encourage you to install the CTP 2.0 release of SQL Server 2017 and give us feedback. Thank you.
Thank you.